we can perform row and column operations on a matrix. These operations are particularly helpful when finding the inverse of a matrix, solving a system of linear equations, and finding determinants. There are 6 operations available on a matrix, 3 on rows and 3 on columns. Before we start with the operations, we will see some conventions. Suppose we have a matrix A with m rows and n columns. We denote the ith row as R subscript I and the pth column as C subscript P. Now, let's start exploring the operations. The first operation is the interchange of rows or columns. We have a matrix A. Let's interchange rows Ri and Rj. This is represented by a notation as shown. The symbol signifies the interchange of rows. Therefore, matrix A after the operation is as shown here. Let's see an example. Here, we have interchanged rows R2 and R3. Now, let's interchange the columns of a matrix. Here, we have interchanged the elements of the columns CP and CQ. An example is shown here. If we interchange the first and second columns, we get the matrix as shown. We will now see how the elements of a row or a column are multiplied by a non-zero number. If we multiply the ith row of a matrix with a non-zero constant, k, then the notation is as shown. For matrix A, if we multiply the ith row with a non-zero element, k, the resulting matrix is as shown. An example of a matrix whose first row is multiplied with 1 divided by 5 is shown here. If we multiply the pth column with a non-zero element, L, then the resulting matrix is as shown. A matrix whose second column is multiplied by 4 is shown here. Next, we will see how the elements of a row or a column are added to the corresponding elements of any other row or column multiplied by a non-zero number. Suppose we want to add the elements of the ith row to the corresponding elements of the jth row multiplied by a non-zero element, k. The operation is written as shown. Let's see how it performs over matrix A shown here. First, we will multiply the jth row with the non-zero constant k. Then we add these elements to the corresponding elements in the ith row. Let's see an example. Here, we have replaced the second row of the matrix according to the operation. A similar type of operation over the columns of a matrix is shown here. In this operation, we are replacing the elements of the pth column with the corresponding elements of the pth column, plus the elements of the qth column multiplied by a non-zero constant, L. Let's see how this is done with the help of matrix A. According to the operation shown, we will replace the pth column with a new column. After the operation, matrix A becomes like the one shown here. Let's see an example. Here, we have replaced the elements of the first column with the corresponding elements obtained by the operation.